Welcome back to the chart table. For this video, I'm going to show you a little method to help you out with your ETA or ETD, estimated time of arrival, estimated time of departure. And this method is what I like to call the airplane method. Once I've started doing this and I started teaching it, this types of problems that you see on certain tests, maybe your advancement exams, became a little bit easier because you found a way to illustrate it. It used to be just a little chart, you just write in all the times, Zulu times, local times. Could get a little confusing if you get confused with that kind of stuff, a bunch of numbers. But this illustrates it, and hopefully learning it will help you out. Another name that other people have given it was the top hat method, but I always call it an airplane method because that's all I learned. So basically, you draw this little bracket. And you write in where you're starting. We're starting in Norfolk, Virginia. And we're going on deployment. And usually Norfolk ships, their very first spot they hit on deployment is Rota, Spain. So we end up going to Rota. For this case, we're going to find our estimated time of arrival. So we're going to be leaving Norfolk at 0800 01 May. Now you can think of this in different ways. With no information, we can't successfully get in the air to go to Rota, Spain, if you're thinking airplane. We need a lot of more information before we do it. We need a distance between Norfolk and Spain, and you'll be able to find that in your distance between ports publications, or you can Google it, and I got a rough estimate of 3,500 nautical miles. You need a planned PIM speed. Most ships go between 10 and 12 because they're not in a rush to get there, so we'll just do 10 knots. All right. Once we have that information, you have two of the three integers to go into the D-Street triangle. Distance equals speed times time. Distance divided by speed gives you time. Distance divided by time gives you speed. We need to find time. So we're going to take 3,500 nautical miles, which is always in nautical miles. Knots, or nautical miles an hour, if you didn't know what knots meant, and hours. 3,500 divided by the PIM speed, we get a total amount of hours, 3,500 hours. Now we want to convert the hours to days, hours, and minutes. Go ahead and pull out your calculator. And the very first thing you're going to do is take 350, divide that by 24. You get 14.58 in running threes. Just take the 14, write it down. And your calculator, minus 14, and times the remainder by 24. You got 13.9, a bunch of running nines. I'm going to go ahead and round that up to just 14. 14 hours. When you round that up, you won't have any minutes, but I'm still going to write it down. Just because in future questions, you might get an actual usable decimal to multiply by 60 to get your minutes. But for this case, it was so close, this is what I'm going to use. Now with this information right here, can we safely get up into the air? No, there is one more thing we need to do for both ports, and we got to find our zone description. I'm going to erase this for a little bit more room, and that's where this part comes in. That is the zone description of that area. Now in May, our zone description will be +4 Quebec. If you need to figure out how to find your zone description, look at previous videos. But if you are in the time of the year between March and November, you're in +4 Quebec. Between November and March, you're in +5 Romeo. So I'm going to write +4 Quebec. Now for Rota, Spain, they recognize daylight savings as well. And this time of the year, they are in +2. Any other times, they're in +1. Now with all this information, we can successfully get into the air and fly over to Rota, Spain. Now what we're going to do is apply everything. Everything down here is local. We're going to convert everything to Zulu, and then eventually convert everything back to local. And everything up here is Zulu. Now applying the +4 hours. All you do is add 4 hours. L to Z, leave it be. So 0800 plus 4 hours is 1200, and it's still on the 1st of May. To get over the road to Spain, we have to apply the distance and time. 14 days, so that will be 15th of May, and plus 14 hours. So 12 plus 14, that is 2600. That is not a time that we recognize in the military. If it goes over 24,000, you went into the next day. So we'll subtract, well, first, since we were in the next day, turning this into 16 May, and then we can go the 2 hours past 2400, making this 02. So basically all we did was, say you keep going past that day, 2300, 2400, which we say 0000, then it goes to 01, 02. If you go into the next day by 2 hours, you're going from boom to boom, 0200. So to make this a little neater, 16 02. Now we flew across the pond. We're in Rota, Spain, but we need to recognize their time zone. To convert it back to local, remember Z to L, reverse the spell. All we're going to do is take this -2, reverse the spell, or this +2, reverse the spell to -2. All we're going to do is subtract 2 hours. So 0200 minus 2 hours, that is midnight on the 16th of May. And that's about it. That is ETA, estimated time of arrival, and the port you want to go to based off information that you already had. You want to leave here, what time will we get there based off all this information? Estimated time of departure, you have this information. You want to get there at midnight on the 16th of May, and you just work backwards. L to Z, leave it be, you have +2, got your 02, 16th of May. You would subtract the distance and time to get 1200 on the 1st of May, convert it, 08 May. Right? ETA, ETD, fairly simple way of doing it. If you prefer the chart method and just write everything out on top of each other, by all means, that's one way to learn it. This is another way of learning it by illustrating it.